So hello, welcome back to my YouTube channel, and the problem that we are going to solve today is related to the course of materials and metallurgy, and the topic is related to diffusion. The problem is 5.28. The problem reads the diffusion coefficients for carbon in nickel are given at two temperature as follows. We have a table over here with two columns. In the part A, we are asked to determine the values of DO, that is constant DO. Usually in the numericals of diffusion we have given it, but in this problem we are asked to find it, and QD in the part A, and later in the part B we have to find the magnitude of D, that is diffusion, at temperature 850 degrees Celsius. So on the basis of this we can conclude that since we have temperature 1 is equals to 600 degrees Celsius and temperature 2 is equals to 700 degrees Celsius, the D value given is 5.5 exponent minus 14 meter square second. These are coming from the you can say this is D1 and this one will be D2. These are coming from the table of the problem. Okay, so since we have to find, in part B we are asked to find the value of D at temperature 850 degrees Celsius. So we understand that we can use Arrhenius relation over here. What is Arrhenius relation? It is basically equation that is D is equals to D naught exponential minus QD over RT. Okay, so what we are going to do in the next step, we are going to very simply convert the temperatures into Kelvin. This is 600 for Kelvin, 273 we add in the degree Celsius, so 700, 800, 700, 800, 820, 873 sorry I think, and over here 973 Kelvin. Let me check if I am right. So after converting the temperatures into Kelvin, we will use this equation A, that is Arrhenius equation, and form two separate equations for this one data set and for this second data set. How we will do it, let me show you. So our equation was this was our basic equation. Okay, remember over here R is gas constant type 8.314 kilojoule over mole into Kelvin. I think this is the unit, correct? You can check it. Now we will transform this equation for two data set. How are we going to do it? Let me show you. This D naught over here is multiplying, so on the left hand side of the is equals to, it will divide. D over D naught is equals to exponential minus QD over RT. Okay, now take ln on both sides, so ln D over D naught is equals to ln into exponential, just taking ln logarithm on the both sides, so this ln will cancel out the exponential, and we know ln D over ln and bracket anything dividing will turn into ln D minus ln DO. It is a property. The remaining equation stays same. Now what we are going to do, we will just change the values in such a way ln D1 is equals to ln D naught, changing this over there, then we are left with, I think, plus this, yes, Okay, since this is d1, so the temperature over here will be d1. This is equation number 1. Similarly, ln d2 is equals to ln d0. The d0 remains same because we have to find it. Okay, and this is always given in the problem, but in this specific problem we are required to find it, and the remaining equations remain same. So these are the two equations. Now if we remember in the part A what we are required to calculate, we are required to calculate d0 and qd. Qd is the activation energy and d0 is the constant of the diffusion. So we have already formed the two equations on related to the given data. Now we are going to subtract both equation 1 and 2. Subtract both equation 1 and 2. By doing this we can eliminate the same factors of the equation, and it will be easier and convenient to find first variable, either it will be DO or QD. Let's find out. So on subtracting, our equation must look like something like this. Okay, first we are going to use it in terms of, I am multiplying this. Okay, ln d naught. Okay, qd over r d2. Okay, now simplify this very equation. Okay, ln d naught minus qd over rt1. Now we are going to merge the brackets, minus plus minus ln d naught minus plus qd over rt2. Since this and this have opposite signs, so these will cancel out. As I said earlier, something like this will happen. Okay, this is ln d1 minus ln d2. So apply the property over here, ln d1 over d2 is equals to, we can take common qd and r, because it will be, r is a gas constant, or we can say just a constant, so it will remain same for both cases, as well as qd. So our equation will something look like this. Only the temperature are going to left inside the equation or bracket. Since we know the value of d1 and d2 that were given in the problem as in the table, and d1 and d2 too, so now we can arrange the equation in terms of d. Arrange in terms of qd. So what will be our new equation? It will be something like this. I was there. Okay, and this whole thing will be below this in the denominator, so it must look like this. Now put values. So qd is equals to, let me see. So qd is just going to be equal to, convert the minus, since we remember we have a minus sign over here, so either convert it over here or take it here at the end. Consider your answer in negative, or you can neglect it. Let's see what we will do. So not consider here. Okay, minus 8.314 into what is ln into what is the value of d1, 5.5 exponent minus 14 divided by 3.9 exponent minus 13 whole divided by 1 over what is the temperature 600, that is 873 I think Kelvin, something like that, and the other value is 973. So when we will solve this complete by calculator, I have calculated it already by pausing the video. The value we are getting is 13800 this, yes, joules per mole, or if we convert it into kilojoule, that will be 138.3 kilojoule per mole. The half work of the first part A is already done. We have already calculated QD. Now we are going to calculate the DO, or we can say D naught. How are we going to calculate D naught? It is very simple. We can either put D naught in the equation 1 or in the equation 2, but in my case I will be preferring using equation number 1. You can use both equation because QD is the result of the subtraction of both. So the first equation was D1 is equals to D naught into exponential minus QD over RT1. So when we will put the values, let me see the data. Yes, we need D naught. Okay, we want to find D naught. So D naught is equals to D1 over exponential of what? Minus QD over RT1. So D naught is equals to 5.5 exponent minus 14 whole divided by exponent minus 19 minus 19.055. How this come from here? I'll show you, but you have to calculate it on your own. This is exponential. Minus QD we put 138,300 and the denominator 8.314 multiplied by 873. This is the value we put in the calculator, the whole denominator. So we get, or either put this and then take exponential, it's up to you. The final value by dividing whole this term is 1.04 exponent minus 5 meter square over second. So part A is completed. Now for part B. In part B we were required to find D at temperature of 850 degrees Celsius. So it is very simple, use Arrhenius equation. It is D is equals to D naught into exponential minus QD over RT. So D we are going to find D naught we just calculated. We are going to use that D naught, 1.04 exponent minus 5, okay, into exponential of QD we have already calculated, 138,300 over 8.314 into, okay, so this temperature is going to be converted in kelvins. So 850, I don't have the value of this, 850 plus 273, 1123 Kelvin, okay. So 1123. So after using calculator on this whole drum, We are left with 3.84 exponent minus 12 meter square over second. So this is the answer of the B part. So that's all. I hope you like the video. If you do, do subscribe my channel, and we will meet in the next video. Take care. Goodbye.